Hey everybody, it's Mr. Herman with another video. I'm back with one on dilations today. Today's Thursday, May 7th, 2020. And we're going to be working on dilations. This is our last day of transformations, and then tomorrow's going to be a study guide and a quiz. And I plan on making a video tomorrow also, again, to remind you what you're doing as far as those two things. So let's get started on this one. The plan is to look over some of the basics for here first. Let me zoom in a little bit closer. What happens with a dilation? Well, this is kind of like if you ever go to the eye doctor. Maybe you've been to the eye doctor before, and they put those drops in your eye so they can look inside your eye with that light. Well, they dilate your pupil. That makes it bigger. So what really happens with dilations is something is either shrunken or enlarged. So I'll say, let's go enlarged here first. It's enlarged or it's shrunk. It's made larger or smaller with respect to a fixed point. We're always going to deal with the fixed point being the origin, just like we rotated, same thing. So let's start with, this is actually a pretty easy one compared to yesterday. I think it is. There's less rules to remember. Yesterday had a lot of rules kind of. So let's try this first one here. It wants us to draw the image after a dilation having a scale factor of 2. Okay, scale factor of 2 means you're going to be doubling all the sides. Doubling the side lengths, basically, okay? So let's take a look at this. So this first one, I'll take the A prime, B prime, and C prime. Can barely fit that in there again, as always, but we'll try and get it in. Take it times 2. So 2 times 2, this is the times 2 we're using right here. So 2 times 2 is 4. 3 times 2 is 6. 3 times 2 is 6. 1 times 2 is 2. 1 times 2 is 2. 2 times 2 is 4. So each of those numbers are twice as big. So let's go ahead and graph this and see how it looks. Since we're dealing with it in one quadrant, it's going to stay in that quadrant. It's going to get bigger. It's going to kind of extend bigger in this quadrant over here. So let's go ahead and make it and see what it looks like. So 4, 6 would be 1, 2, 3, 4. 1, 2, 3, 4. 5, 6. There's the new A prime. 6, 2. 6, 2 is right here. Look how we can see that's the segment AB right there. This right here, see? And then we got 2, 4. 1, 2. 1, 2, 3, 4. Just past it. It can overlap too, by the way. It happens. Kind of get it in there. And there's our new shape. It's bigger. How big is it, though? Is it twice as big? It's not twice as big. You would think that. It's actually 4 times as big. You take the scale factor of 2, and you square it. If the scale factor is 3, it'd be 9 times as big. So that means I could fit 4 of these inside here. The area is by a factor of squared. The scale factor squared tells you the area is 4 times as much. So it's not equal like it was before. Let's try this one here. Actually, we're going to skip this one. Let's go to the bottom ones. I think it'd be better to do those. They're a little bit bigger. Let's go on to what happens here, though. How about the pre-image and the image? What can we say about them? They are definitely not congruent, but they are similar. They are similar. Similar means that they are a shrunken down or enlarged version of each other. Same angles, corresponding sides are congruent. I'm sorry, not congruent, but proportional. So corresponding angles are congruent. The angles are the same. They don't change. But the sides are proportional. In other words, let's go back up to this picture real quick right here. In other words, if I go like this and I say, this side is twice as long as that side. This side is twice as long as this side, and this side here, CB, is twice as long as this side. But again, the area is 4 times as much. Let's try one of these one out here now. Let's make this a little bit smaller. Here we go. So I can fit that in just right. There we go. Perfect. Okay. Let's draw that pre-image first. So -1, -1. That's right here. Then we got -1, -2. Ooh, this is small, isn't it? And then -2, -1. Well, that's a tiny triangle. Look how small that is. See? Tiny. And it has a scale factor of 3. That means we're going to multiply each of the coordinates all by 3. So I'll say A prime B prime and C prime are new dilated points. Also, I wanted to remind you, as I'm looking through the homework and I put some notes on some of your homework here, a lot of us are not drawing the images. You should be drawing them also, not just doing the coordinates. So please include this sheet or your own graph paper, which many of you are doing too, and it looks really nice. So we have times 3. So -3, -3, -1 times 3, -3, -2 times 3, -6, -2 times 3, -6, -1 times 3, -3. Now let's graph this. Think about what's going to happen now before you even do it. You might have already been able to tell because it kind of gives it away. But remember, it's enlarging based on this point here. So it's going to kind of be out here somewhere, like in that section there. So let's go ahead and draw it and see. -3, -3. We got -3, -6. 6 right there. That's that segment right there. Then -6, -3. Right there. And you can see it is quite a bit larger. Remember, dilations can be increased or smaller. This one is an enlargement. Notice it's the exact same looking. So that means that the angles are congruent, the sides are proportional. So this side is 1, this side's 3. It's 3 times bigger. This side, whatever it is hard to tell. It's going to be a radical amount. Of course, it's not going to be exact. It's irrational lengthwise, but it'd be hard to get a decimal there. But it'd be whatever this is here times this, okay? Let's try this next one. So we got EFG, and let's go ahead and graph that. So 4, 2. 4 2's right here. And we got 6, 3. 6 3's right here. 3, 4, 5, 6. And then 4 4. 4 4 is right here, I think, isn't it? Looks like 4 4 to me. Okay. Let's draw that one in. This one says it has a scale factor of 0.5. Well, we're not going to divide by that. We're going to multiply by 0.5 or divide by 2 if you want. You can do that too. So divide these all by 2. Times a half is the same thing. So I've got E prime, F prime, G prime. Let's see what we got here. We're going to take half of this. So half of 4 is 2. Half of 2 is 1. Half of 6 is 3. Half of 3 is 1.5 or 1.5. Then half of 4 each time is 2. So let's take these and plot them. 2, 1. Right there. 3, 1.5. 1, 2, 3. 1.5 is right here. And then 2, 2. 2 2's right here. Look at how tiny that thing got. There we go. And there's our final triangle. How many of these would fit inside here? If you're not sure, remember this is twice as big, isn't it? So like see the 1 and the 2. So scale factor would be a half to go to here, but to get to here, it's double. So it'd be 2 squared. So there'd be 4 of these inside here. If you want to try and draw it out, you'll see it does work out. They fit in there. Kind of in a weird way, but if I kind of draw it like this, watch. On the side, you can see it here. They kind of go like this. So here'd be 1 right here. And then the other ones are like this. 1, 2, 3, 4 of those would fit in there. All right, that was great. So much fun doing that with you. Check in tomorrow for a video. I'm going to try to have a video tomorrow also about the study guide and the quiz to make sure you do it right and turn it in correctly. Have a good time. We'll see you soon. Bye-bye.